All right, so sampling techniques and misuses of statistics. So that's what 12.1 is all about. So let's see what they mean by all this sampling techniques and misuses of statistics. So this is going to just be a lot of definitions and terms that, that you want to learn. So upon completion, you're going to want to understand sampling techniques, what that means. And these are the different ones that we'll look at: random sampling, systematic, cluster, stratified, and convenient sampling. Those are the different types of samplings. And then the misuses of statistics. So what is statistics? Well, according to this definition, it's the art and science. So it's a combination of both art and science of gathering, analyzing, and making inferences, which are just predictions from numerical information, which we call data, that you obtain from an experiment. So you conduct an experiment, you collect the data, and then you gather it, you analyze it, and then you can make inferences on it. And that's basically what statistics is. So there are two kind of different branches. The first branch is called descriptive statistics, and the other branch is called inferential. Descriptive is concerned with the collection, organization, and analysis of data, and the inferential is concerned with the making of generalizations and predictions from the data. So this is kind of what you're going to use to make predictions, and this is what you're going to use just to collect and analyze data. All right, so usually this comes before this. All right, a statistician's interest lies in drawing conclusions about possible outcomes through observations. The population, so there's our first definition, or one of our first definitions is a population, which consists of all items of interest or people. And whereas a sample is just a small collection of items from the population. So maybe the population is all teenagers in the United States. That would be the population, maybe. Maybe you're conducting a study on the effects of social media on teenagers. So the population would be all teenagers in the United States. But maybe you just sampled a few teenagers from Compton College or from the neighborhood. That would be a sample. Maybe you only gathered 100 signature or 100 sampled 100 people, but the United States has millions of teenagers, probably, I don't know how many, but a sample is just a small collection from the population. So that would be an example of the difference between population versus sample. So some versus all. All right. Statisticians, when a statistician draws a conclusion from a sample, there's always the possibility that the conclusion is incorrect. So maybe from the 100 people that they sampled, maybe the conclusion was that there was no ill effect from social media. But I think we know that there are, at least there's some studies that have been done that show that there are some harmful effects of social media on teenagers. So maybe this is not a large enough sample. Maybe you have to get 1,000 or 10,000 or something larger. So sometimes you won't always get the correct conclusion. Most of the time it might be because the sample is too small, or because you didn't gather the data in a good way. The sampling techniques, this is a good way to get data. Random sampling. So random sampling occurs if a sample is drawn in such a way that each time an item is selected, each item has an equal chance of being selected or being drawn. So that's called random, when everybody has the same opportunity or the equal chance of being drawn. So that's the best way to collect data, is by random sampling, because there's no bias. Maybe if you saw some kids that were like certain type of teenagers, maybe you looked at them and you're like, that person probably isn't on social media. This person is, so I'm going to ask this person. So maybe you have a bias. But if you're just doing it randomly, then you're going to get better data that's not biased. All right. When a sample is obtained by selecting a random starting point and then selecting every nth item in a population, the sample is systematic. This is also a good way to do it, I would say. So maybe you're I don't know, outside of a supermarket and you're looking for teenagers to ask a question about social media. So maybe you get not the first, second, third. Maybe you get every third person. Oops. So 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. So maybe you ask the third person, the 6th, the 9th, the 12th, the 15th, etc. So that would be an example of systematic sampling because you're getting every third person. So that's one way to collect data. So there's two ways so far. Random, which is you just selecting anybody at random. And now systematic, you're selecting every third person, or it could be every fifth person, or any, it could be any nth person. All right, cluster sampling is sometimes referred to as an area sample because it is frequently applied on a geographical basis. So essentially the sampling consists of a random selection of groups of units. So let's see, let me look at that and the difference because these two are very similar. Okay. All right, so maybe this one, it says geographical. So maybe you have some region and maybe you have, I don't know, Compton, whoops. Long Beach, Linwood, maybe Carson. All right, so you break up the region into clusters, and then here, cluster. Yeah, you're sampling random selection of groups of units. So maybe you're going to get everybody from Long Beach and everybody from Linwood. So that would be an example of cluster sampling because you're getting everybody from here and everybody from here. And then you're going to make a generalization based on the data. You're going to say, oh, okay, I guess most of the teenagers in these two cities are affected in a negative way by social media. So I'm going to make a conclusion that everybody is affected in a negative way by social media because I sampled these two cities and the results are going to generalize to the entire region. So that's a sample of cluster sampling. All right, let's look at stratified. So stratified involves dividing the population by characteristics called stratifying factors such as gender, race, religion, or income.
Professor, couldn't you use the same base information like you did in the last example, but instead you would say like instead of it being all just about like the population size, it would be like more men than women live in Long Beach than in Linwood, or people pay more money for rent in Carson versus Compton. So couldn't you use like the same like base?
Yeah, you could actually. That's a good point. Yeah, that's a good point. So in this case, stratified, I would say that you would break it up into groups similar to what we did in the previous example, but maybe you can choose one of these factors like race or religion. Let's just go with religion for this example. Maybe you have all the Christians, Muslims, maybe you have atheists, and what's another one? Maybe
Catholics.
Which one?
Catholics.
Catholics, right? Catholics. Oops, I misspelled that. Catholics. All right. Catholics. All right, Catholic. So, yeah, so you would stratify by religion, and then maybe you would select a few, you would maybe get a few Christians, a few Muslims, a few atheists, a few Catholics, and that's how you wouldn't get all the Christians, all the atheists. You would just get a sample from each group, and that would be called stratifying. So, and you can do that by income or by gender or by race, or there's different, or by, yeah, anything that you could think of, I guess. So these two are very similar. The difference between them, I think the cluster, you get everybody from the cluster. And over here, you're just getting a sample from each cluster. Or from each cluster. You could call it a cluster too. All right, convenience, that just means you're just uses data that are easily or readily obtained. So this one can be extremely biased. So I think this is one of those that you kind of want to avoid. You're just collecting data that's convenient. So maybe I'm trying to think of an example. Maybe it's like your siblings or your cousins or your friends, only people that are related to you, you would ask them. But maybe they might be biased because maybe they're really into social media, or maybe they're not into social media at all. And so you don't want to just do it out of convenience just because they're easy to obtain because they're your relatives or they're your friends. You want to make sure it's more random. So this can be extremely biased. So that's kind of one of the samplings that you want to try to avoid. All right, here's our first example, identifying sampling techniques. Identify the sampling technique used to obtain a sample in the following, and then explain your answer. So every 20th soup can coming off an assembly line is checked for defects. Anybody know which of technique this would be? So let me write the possibilities. There is random sampling, systematic, cluster, stratified.
Would it be systematic since it's the same
Added,
can every time?
Yeah, exactly.
yeah.
So these are the different options: random, systematic, cluster, stratified, or convenience. In this case, since you're getting the 20th soup each time, that's a systematic process. So it's kind of like getting, over here I did the every third. So that would be every 20th. So yeah, that is exactly right. This would be systematic. So I'll just highlight it, systematic. All right, and you can just say because it's every 20th can. That's systematic by definition. All right, let's look at this one. A $50 gift certificate is given away at the annual bankers convention. Tickets are placed in a bin and the tickets are mixed up, and the winning ticket is selected by a blindfolded person.
Random.
Random.
Definitely random. That is right. Because I'll just say
They're pulling from a bucket, like.
At random.
yeah, because they're putting at random and everybody has an equal chance of getting selected because everyone has an equal chance of being selected. All right. Cool. So, all right. Why don't you guys read this one and then let me know what you guys think.
Would that be cluster? Because they're talking about like a neighborhood area and
Yeah,
cluster is geographical.
yeah, you're right. It is cluster because it's like the key is it's like a neighborhood, so
Mm.
regions. And also they're selecting everybody, all children from
All
the
children.
instead of just a sample from each neighborhood. So that would have been stratified if you just got a sample from each region. But in this case, you're selecting everybody in that cluster. So this is definitely cluster sampling. Because you are dividing the region and selecting everyone everyone from the selected schools. You're not selecting every school, but you're just selecting some schools and then getting everybody from that school, from the selected schools. All right. So that is called cluster sampling. And let's see what the next one is. All right. Let me know what you guys think this one is.
It's convenience, because like the first 50 people, that's like super extremely random. And then who's to say the first 50 people are gonna even be like registered to vote, if they even pay taxes or anything like that. So it's convenient. It's like, oh, just get the first 50 people and be done.
Yeah, it is convenience because they're just taking the very first 50 people that show up. And so that's just out of convenience. They're not doing like every 10th or systematic or random. They're just whoever comes up first 50, that's the most convenient. So definitely convenient sampling because they are choosing the first 50 people. All right. All right, so let's see this one.
Stratified because the vehicles are being broken up into different categories.
Yeah,
And then one is like vehicles are selected from each category, and the keyword is random sample. Yeah.
yeah, from each category. Yeah, you're right. So they're breaking them up into different categories. So that's either cluster or stratified. And then if it would have been cluster, they would have selected, maybe, let's say they selected midsize and SUV. That means they would have selected all the midsize cars and all the SUVs. That's cluster. But in this case, they're just taking a sample of compact, a sample of midsize, a sample of full size, a sample of each one. So that is stratified. Since they are taking a sample of each category. All right, since they are taking a sample of each category. So that is the definition of stratified. So I think that's it because we've done an example of each one: random, systematic, cluster, convenience, and now stratified. All right, so misuses of statistics. So as you may be aware, statistics can be misused by individuals or by businesses that are trying to sell you a product maybe, or advertising firms like maybe the tobacco industry. They want to understate the harmful effects of smoking maybe, or there's many different examples they want to just use it to their own advantage. So When examining statistical information, consider the following. Was the sample used to gather the statistical data unbiased and of sufficient size? So remember, we said the sample size has to be large enough, because if you only get a small sample, it might not be representative of the entire population. Is a statistical statement ambiguous? Could it be interpreted in more than one way? Sometimes they'll ask questions in a way that can be interpreted differently, and so it's not very clear. And so the people that are being sampled aren't going to really respond in a way that's clear. All right. For example, what is not said? 4 out of 5 dentists recommend sugarless gum for their patients who chew gum. So in this advertisement, we do not know the sample size. Okay. So we don't know how many people were asked. Maybe they just asked 5 people. Maybe they asked 10 people. Maybe they asked 100 people. We don't know. We just know that 4 out of every 5 recommend sugarless gum. So we don't know the sample size. That's one thing. And the number of times the experiment was performed to obtain the desired result. Okay, that's the same thing as the sample size. The advertisement does not mention that possibly only 1 out of 100 dentists recommend gum at all. Okay, so they're saying that 4 out of 5 dentists recommend sugarless gum for the patients who chew gum. What if they don't chew gum? Does the dentist recommend gum at all? It says here, the advertisement does not mention that that possibly 1 out of 100 dentists recommend gum at all, because they're saying only the patients who chew gum, the dentists recommend 4 out of the 5 dentists recommend sugarless, but we don't know how many doctors recommend gum at all. So that's another misleading thing that they don't tell you in the fine print. All right. In an advertisement for golf balls, the driver golf ball is hit and another brand golf ball is hit in the same manner. We are told that the driver golf ball travels farther, and we are supposed to conclude that the driver golf ball is a better golf ball. And the advertisement does not mention the number of times the experiment was previously performed. Yeah. So what if they only did this like 2 times, and by luck, this ball went farther, but 2 times is not enough times to make a broad conclusion. So I would say that that is really important. It doesn't mention the number of times the experiment was performed. All right. Possible sources of bias include wind speed and direction. All right, so we don't know. Maybe they were hitting the balls when there was a lot of wind, or the direction. Maybe they hit the good ball when the wind was not blowing, and the bad ball when the wind was going against them. So there's all kinds of different factors. No 2 swings are identical. What if the first time they hit it, they used a really good swing technique, and the second time with the bad ball, they didn't use a good technique? Or a professional golfer hit it the first time and an amateur hit it the second time. You know, there's all kinds of different things that could have gone wrong here. The ball may land on a rough or smooth surface. Yeah, depending on if the ball lands on grass versus sand, or I don't know, there's different scenarios. The ball could have landed in water. So things that are not said oftentimes create bias. Okay. Ambiguous or vague. Vague or ambiguous words also lead to statistical misuses. The word average is one such culprit. There are at least 4 different averages, and we're going to discuss the word average in statistics in section 10.12.3, which is coming up later. Each is calculated differently, and each may have a different value. All right. During negotiations, it is uncommon for an employer to state publicly that the average salary of employees is $45,000, whereas the employees' union state that the average is $40,000. Who's lying? Actually, both sides may be telling the truth. Each side will use the average that best suits its needs. So there's different averages. There's mean, there's median. Those are 2 examples of averages. So maybe the employers are using this one and the union is using this one, and that's why they're getting different results. Whichever makes them look better, obviously. Charts and graphs can also be misleading, even though the data is displayed correctly. Adjusting the vertical scale of a graph can give a different impression. So let's look at an example. So the vertical scale, so that would be this right here. That's a vertical scale. While each graph represents identical information, the vertical scales have been altered. This one appears to be going by fives. 5, 10, 15, 20, 25, 30, 35, 40. This one is, notice this squiggly line? That means it just jumped, and we don't really know the scale here. We just know that it's going from 25, 26, 27, 28, 29, 30. So now they're going by ones. So this one's going by ones, but they jump. And this one's going by fives without a jump. So this is the same as this, but they look different. You might think, oh wow, this stock is doing really well. It's increasing. I'm gonna buy some shares. But the reality is it's not increasing as much as you think. So someone who's trying to sell this stock might show you this, but it's more the growth is not as strong as it appears to be. So that's how they can mislead you. All right, here's another one. See, there's the squiggly lines again. That means they're jumping. This one does not have the squiggly, and this one's increasing by 20, 20, 20, 20, 20. This one's going by probably 96, 97, 98, 99, 100. So look at that difference. You're going to say, this one just grew big time. It went from, in 1 year, it just increased so much. But the reality is, it just increased a little bit. So like maybe for COVID, the number of deaths in COVID is so dramatic. And over here, it's, well, it is, but not as much as this is. Or, you know, you can use any example. Here's another one. Consider a claim that if you invest $1 by next year, you will have 2. This type of claim is sometimes misrepresented. Actually, your investment has only doubled, but the area of the square is 4 times as large. So they doubled. This is 1 by 1, which is 1. This is 2 by 2, which is 4. So the square is 4 times as big, but the stock is only twice as big. So they can mislead you with shapes like squares. If you double the side, that means you're increasing the area by 4 times. So that's another way they can get you. Or if you use cubes, 3 dimensions, this is a 1 by 1 by 1 cube. So the volume is 1, 1 times 1 times 1. But if you make this the volume a 2 by 2 by 2, then that's going to be 2 times 2 times 2 is 8. So this has 8, and this is only 1. So now the cube is 8 times larger, but the stock is only twice as more. So the volume increased by 8. So that can be misleading because you can see this and this, and you say, wow, that's such a drastic difference. I'm going to go with this because it's growing so fast, but not quite. A circle graph can be misleading if the sum of the parts does not add up to 100. So we know that in a circle graph, all the percentages should add up to 100. But if you look at this, this is 49, that's 42, 37, 24, 16, 15. Clearly, that does not add up to 100. That's way more. So this would be misleading. All right. The graph on the previous slide adds up to 183. A graph other than a circle graph should have been used to display the top 6 reasons Americans say they use the internet. Okay. So despite the examples, you should not be left with the impression that statistics is used solely for the purpose of misleading or cheating the consumer. So these are just things to be looking out for, but you shouldn't assume that that's all that people do is everybody has bad intentions. Yeah, I mean, most of the people I think have good intentions, and I'm not trying to mislead you, but you do want to be careful. Charts and graphs. There are many important and necessary uses of statistics. Most statistical reports are accurate and useful. So there it is. Most of them are accurate and useful. You should realize, however, that the importance of being an aware consumer. All right. Cool. Oh, wow. So we went through that whole thing pretty quickly. So there was just a bunch of definitions, but I think this is a good time for a break. And I did want to jump into the next section today because we have to. All right, so we are now starting our section 12.2. Let me change this title to read 12.2 instead of chapter 13. All right, let me do something. Okay, section 12.2. Data blank such as measurements. Data is, that's weird the way they do that. Data, let's see, what do they want us to write there? I'm thinking it's this data is, no. Okay, let me see. I'm trying to think of what they want us to write in that blank. All right, well, let's just leave that blank. Data is items that have been collected, maybe items that have been collected, I guess. Or information that has been collected. Sorry, information such as measurements, gender, survey responses that have been collected. All right, table A represents a group of selected countries and information regarding these countries as of October 2007. All right, so France, they're a republic. Their life expectancy is 80.59 years, and their population is 63.7 million. All right, so out of these 4 countries, they have the highest expected value. Maybe it has to do with their lifestyle. Maybe they're more relaxed out there, less stress. Maybe they eat more fresh foods. Maybe they don't process their food as much as we do. Who knows? The point is, they live on average about 2.5 years more than we do. All right. Population, the complete collection of data to be studied. All right. So an example would be, let's say we're trying to figure out how many people at Compton College are vegetarian. So the population would be, anybody know what the population would be in this case? Well, it would be everybody at Compton College. That would be the population, everybody at Compton College. The sample is a set of members selected from a group or a sub-collection. I'll call it a sub-collection of members selected from a population. So maybe it's maybe it's 100 students at Compton College were surveyed to ask them how many of those 100 are vegetarian. So that would be a sample because you're not taking everyone from Compton College, you're just taking 100 students from Compton College. So that would be an example of a sample versus a population. A parameter is a blank measurement describing some numeric measurement describing some characteristic of a population. All right, so maybe it turns out that, let's say 5% of all Compton College students are vegetarian. That would be called a parameter because it's a numeric measurement that describes the population. So that's just an example. A statistic is a numeric measurement describing some characteristic of a sample. So these two things are very similar, but a parameter describes the population and a statistic describes a characteristic of the sample. So P goes with P, population goes with parameter, and S goes with S. A sample goes with statistic. So that's how I remember it. If it's a parameter, it's a characteristic that describes the population. If it's a statistic, it's a characteristic that describes the sample. So these are all just definitions. So P goes with P, S goes with S. All right, let's check our understanding of these terms. So is it a parameter or is it a statistic? All right, let's check our understanding of these terms. So is it a parameter or is it a statistic? That is it describing the population or is it describing a sample? A survey of 200 adults in the US found that 76% regularly wear seatbelts while driving. 76% is a, so is that number describing, is it a characteristic of the population or of just the sample? Well, it's only 200 adults in the US. So of the 200, 76% of those 200 wear a seatbelt. That's describing a sample, not everybody. It's just a sample. So that would be a statistic.
Oh, okay.
Remember, sample S goes with S, P goes with P. Sample statistic, parameter population. All right. Currently, 42% of the governors of the 50 United States are Democrat. 42 is a, so what do we think? Is this a parameter or a statistics? Is it describing the population or the sample? Well, there's only 50 states in the US, and they're saying of those 50 states, 42 are Democrat. So is it describing all of the states or just a sample of the states?
A sample?
Well, in this case, it's describing all 50 states.
Oh, okay, okay.
So that would be a population,
Population,
therefore parameter,
right.
because it's describing the population. The population is all 50 states in this case. 42% of all 50 states are Democrat, so therefore it's a parameter. So it can be a little tricky. The average atomic weight of all elements in the periodic table is 134.35 unified atomic mass units. Is that a parameter or a statistic? There's a keyword that you should look at here.
All.
All. So that means it's describing all the elements in the periodic table. So therefore it's a population characteristic, which means it's a parameter. So all, usually when you see the word all, that means it's referring to a population, which in this case would be a parameter. Alright. A sample, and then here's another keyword, a sample of Americans is selected, and the average amount of time watching TV is 4.6 hours per day. Is that going to be a parameter or a statistic? Is it describing a sample or a population? Here's your keyword.
Sample.
So it's describing a characteristic of the sample, which means it's a statistic. S, yeah, S goes with S. Parameter goes with population. So it is going to be a statistic. All right. So yeah, the keyword is whether all or sample. If it's all, it's a parameter. If it's a sample, it's a statistic. Sometimes they won't say either word, so you have to figure out, well, 50 states, that's everything. That's every state, so that's a population. 200 adults, that's a sample. Therefore, statistic.
Statistics.
Yeah. All right. Wait a minute. Okay, I guess this is still a continuation of it, so we're just going to erase this and just continue. All right, so here's our first example. This is now called a frequency distribution. So let me write that here. Oops. Frequency distribution. So let's look at what that means. So it says one of Mrs. Forbes' students surveyed 20 students who recently took an English placement test and asked them what they scored on the test. The test is out of 50 points. The data is below. So 20 students took a placement test, and these are the scores of the 20 students out of 50. All right, so let's construct a frequency distribution table. So that's what a frequency distribution table looks like. All right, so these are called classes. See the classes? And so anyone who scored between 9 and 15 would be included in this category. Anybody that scored between 16 and 22 would be included here, so on and so on. All right, so we have to count how many people fall in this range. So let's go down, let's go through the data and count how many people scored between 9 and 15 points. So go ahead and count yourselves to see how many people fall into this first class.
Is it 4?
Let's see. 1, 2, 3, 4. Yeah, I think 4 is right. So let's cross them out as we go. 1, 2, 3, 4. All right, so you put a 4 there. All right, now let's figure out how many fall between 16 and 22. I think that's it right there, right?
It's 7?
1, 2, 3, 4, 5, 6, 7. Yes, 7. So 1, 2, 3, 4, 5, 6, 7. All right. Next one would be 23 to 29. So 1, just 1, right?
It's 1.
All right. 30 and 36.
2.
Really? I don't think I see any. 30 to 36.
Oh, no, just wait. No, it's none. It's none.
It's none, yeah. And then finally, well, not finally, 37 to 43. 1,
Looks like
2,
3.
3.
3. That's it, right? 3.
Mhm.
All right, 3. So 1, 2, 3. And then the last one, 44 to 50. 2, 3,
Okay.
4, 5. I think that's 5, right? Yeah, I'm counting 5.
Yeah.
1, 2, 3, 4, 5. All right, so we've gone through every single one, and these should add up to 20 because there's 20 people that were surveyed. Let's just make sure. That's 11, 12, 13, 14, 15, 20. Yeah. That's always a good idea to check just to make sure that you got everybody. All right. A raw ungrouped data, a data containing information on each member of the population or sample individually collected data not yet processed. So if it's not yet processed or ranked, that makes it raw data. All right, so a frequency distribution table, a listing of the data and the corresponding, oh no, I'm sorry, a listing of the classes and the corresponding frequency. So this is a list of classes, and these are the frequencies. All right, so that's what a frequency distribution table is. All right, let's continue here. Oh, all right. So number of values in a specific class. What are the number of values in a specific class? Huh, what do they mean by that? The number of values. I guess that's just the frequency. Yeah, that would be the frequency of each class. So that just means frequency. So that's what we would put in that blank. So let's do that now. All right, frequency. All right, the next, uh-oh, I lost my connection. Let's try that again. Oh, let's continue. So, okay, so the next one says blank class is an interval including all the values that fall within two numbers, normally 5 to 12 classes. The classes should not overlap. Class is an interval including all the values that fall within two numbers. What do we do there? I'm not sure what they want there. Hold on, let me see if I can think about that one. Class, an interval, including all the values that fall within two numbers. Yeah, that's just a class. All right. Class width is also the difference between class width is also the difference between any two consecutive lower class limits or upper class limits. So the class width would be, for example, see how it goes from 9 to 16. The difference between those two numbers is the class width. So 16 take away 9 is 7. So that is the class. And then you could also do 16 and 23. The difference is also 7. The difference between 23 and 30 is also 7. So they should all be the same. Oops. Okay, so that would be class width. The smallest numbers that can belong to the different class, that's the minimum value. Oh, I'm sorry. No, the smallest numbers that can belong to the different classes, that's a lower class limit. Lower class limit. So in other words, the smallest number that can fall in this class would be 9. The smallest one that can fall in this class would be 16. So these are called the lower class limits. And these are called the upper class limits, the largest values. So the largest number that can belong to a different class is the upper class limits. All right, in this formula, the lower limit plus the upper limit divided by 2. So if you do the lower plus the upper, that plus that, and you divide it by 2, that gives you the midpoint. So for example, 9 plus 15 divided by 2 is 24 divided by 2, which is 12. So 12 would be the midpoint of that class. So we call that the midpoint. And you can find the midpoint of each class. The class with the greatest frequency, that is called the modal class. So whichever has the highest frequency is called the modal class. So over here, this would be the modal class, 16 to 22, because 7 is the highest number in this frequency list. So that would be the modal class, 16 to 22. All right, so those are just definitions. All right. All right, let's look at this example. The following frequency distribution table represents employment information on the Alpha Corporation. So these are the number of years of service, and these are the number of employees that fall in these different intervals or classes. So find the total number of observations. So the total number of observations is the sum of this frequency column. You have to add up all these, and that's the total number of observations. So that's going to be 50 right there, 60, 65, 63. I mean 68. So 50, 60, 65, 68. So 68 is the total number of observations. The class width, anybody remember how to find the class width?
It's the lower numbers on the right side. Is it 6 and 1?
Yeah, very good. You subtract those two numbers, right?
You're right.
So 6 minus 1 is 5. So 5 would be the class width. All right. Oops, I should have gone this way. That's okay. Find the number of classes. Anybody know how many classes there are?
6.
Yeah. 1, 2, 3, 4, 5, 6. Okay. We already did this one. Now let's do this one. Find the midpoint of the second class. So anybody remember how to find midpoints of that second class? Here's the formula.
Class plus the upper class divided
Yeah, divided by 2. So 6 plus 10 divided by 2.
Be 8.
Yeah, it's gonna be 8. That's the midpoint of the second class. All right, find the modal class. Or there could be more than one. Which one has the highest frequency?
by 25.
So it's gonna be 11
Oh,
class. Yeah, you want to give the class. So in this case, it would be, this class is a modal class because it has the highest frequency. So that would be it. All right, and then the last question says, find the class limits of the next class if an additional class were to be added.
31 and
that's-
35.
Yeah, that's what they meant here. My bad. This would be the class limits. Class. Because it says class is an interval including all the values that fall within two numbers. The two numbers are the class limits, the lower class limit and the upper class limit. All right, find the class limits of the next class. So,
31
you-
to 35.
all right, how did you get that?
Oh, I took statistics, so I just could look at this and know how to do it because this was my favorite part of the class.
Yeah,
Everything else was worse than this. This was the easiest part of statistics.
yeah, this is the easy part. So yeah, the class width is 5, so you just add 5, add 5, add 5. Keep on adding 5, and that's how you get from 26 to 31 if you add 5. Same thing over here, plus 5, plus 5, plus 5, plus 5. So it is going to be 31 through 35. All right, very good. So that is that. Let's keep going. The following frequency distribution is a weekly earning for a sample of 100 employees selected from a large company. So let's find the class width. So you guys remember how to do that? Class width. We subtract, right? So it's gonna be whatever no. The bigger number should go first. 348.5 minus 199.5 is. I think it's gonna be 49, I think. Oh no. 249? Or I mean 149? Yeah, 149. All right, the next one, find the class midpoints of the third class. So here's the third class. The midpoint is when you add them and divide by 2. So let's add them first. 497.5 plus 646.4, whatever that is. And then don't forget to divide by 2. After dividing by 2, I'm getting 571.95. All right, find the class limits of the next class if an additional class were to be added. So remember how we did last time? I know Tori did it. So here's your class width. What would you have to do with the class width to find the next lower class limit?
Add it.
Yeah, you would add whatever the lower class limit is of the last class, add 149 to it. That'll give you the next one. I'm getting 944.5. And then my upper, same thing. You take the upper class limit and you add the class width again, and that should do it. I'm getting 1093.4.
Yeah, that's what I got.
All right, cool. All right, let's see. All right, this is the last page here. Actually, we're out of time, aren't we? Wow, that was fast. Class went by fast today. That's okay. We can pick up on this, but we'll pick up on number 4 next class, which is Wednesday, obviously, and then we can do the other section 12.3, and then we'll be done. All right, so let me take roll. I didn't realize that time